Okay, so solutions are defined, as you know, as homogeneous mixtures of two or more pure substances, right? I take some salt and I mix it in water and I have a solution. The solvent is what's present in the greatest abundance, and all other substances are considered to be the solutes, the things being dissolved. When an ionic substance dissolves in water, what happens is the solvent, and generally we're talking about water, pulls the individual ions. Okay, so here we have a water. The white parts here are the more positive side of the water. The red is the oxygen, the more negative side. So the more positive side surrounds this negative ion, let's say this is a chloride ion, and plucks it off. And on the other hand, the more negative side of the water would surround the sodium and pluck that off. Okay, and it does what we call solvates them. We call the process dissociation. So when an ionic compound comes apart in water, we call it dissociation. An electrolyte is any substance that dissociates into ions when it's dissolved. Okay, so sodium chloride is an electrolyte because it comes apart as ions in water. A non-electrolyte is something that could dissolve in water, but it doesn't dissociate into ions. It stays together as molecules. Okay, electrolytes conduct electricity and non-electrolytes do not. This is what I wanted to show. Alright, so we have electrolytes and non-electrolytes. Now, all ionic compounds, assuming that they're dissolved, you can assume are strong electrolytes. They will completely dissociate in water. Okay? So none of them are weak and none of them are non-electrolytes. For molecular substances, all strong acids, and those are the ones you had to memorize, are strong electrolytes. Okay? All weak acids and weak bases are weak electrolytes. Remember, they only partially ionize, and it's those, because it's just partially ionized, that it makes them weak. And all other compounds are non-electrolytes. So all molecular compounds, with the exception of acids and bases, are going to be, or covalent compounds, are going to be non-electrolytes. They will not conduct electricity. So, of course, soluble ionic compounds tend to conduct electricity. Alright, so a strong electrolyte dissociates completely when dissolved in water. So this is the link I wanted to show.
An electrolyte is a substance that, when dissolved in water, results in a solution that can conduct electricity. The light bulb will light if the substance is an electrolyte. Sodium chloride, NaCl, is a soluble salt that is assumed to completely dissociate into ions. NaCl is a strong electrolyte when dissolved in water. The solution contains a large number of ions, and the light bulb is brightly lit. Polar water molecules interact with the positive and negative ions of the salt. The positive ends of the water molecules are attracted to the negative chloride ions. The negative ends of the water molecules are attracted to the positive sodium ions. This interaction between the water and the salt ions causes the salt to break apart or dissolve in water. Hydrofluoric acid, HF, is a weak acid which only partially ionizes in water. HF is a weak electrolyte. The solution contains only a small number of ions, therefore the solution is weakly conducting and the light bulb is dimly lit. At equilibrium, a hydrofluoric acid solution contains mostly non-ionized acid molecules, HF, and a small amount of hydrogen ions, H+, and the conjugate base ion, F-. Methanol, CH3OH, does not dissociate into ions when dissolved in water. It is a non-electrolyte. A non-electrolyte solution does not contain ions. Therefore, the solution does not conduct electricity and the light bulb does not light. Methanol molecules contain a polar OH group. The oxygen has a partial negative charge and the hydrogen has a partial positive charge. This charge separation is called a dipole. Methanol molecules are attracted to each other through the interaction of the dipole of one molecule with the dipole of another molecule. Water is also polar, and the dipole of water will interact with the dipole of methanol. These particular dipole-dipole attractions are called hydrogen bonds. The attractions between water molecules and the methanol molecule will break the attractions between methanol molecules, causing methanol to dissolve in water. Note that upon dissolving, the covalent methanol molecules remain intact. Compare this to the dissolution of an ionic compound such as sodium chloride, NaCl, which breaks apart into its component ions in water.
Okay, I thought that was a pretty good animation. Alright, so like it was mentioned in the animation, a weak electrolyte only partially dissociates. We saw the light barely light up with hydrofluoric acid when it was dissolved in water. Okay. Alright. So strong electrolytes, again, are strong acids, strong bases, soluble ionic salts, sodium chloride, calcium chloride. Okay. Weak electrolytes are weak acids and weak bases, and non-electrolytes are everything else, mostly covalent compounds that are not acids or bases.